Now there's one tiny little thing that we still need to do, and that is that we need to be able to take damage. Yeah, because we're evaluating the threat. Where are we? Here. We're calling the utility score for this damage value, right? So we need to be able to take damage, and one way to do that, we want to do it only when we begin playing, is that we want to get our control pawn. So remember that every controller, this is a controller we're working on, has a control pawn, and we can bind an event to on take any damage. So what's actually going to happen is that we probably want to start this after we've set up our behavior tree, and we're going to bind an event to ourselves to say, okay, or rather the character that we're controlling, we're going to bind an event to say when we when this event happens, call us back, call this controller back. So here's where things get a bit tricky. So event take any take any. So for some weird reason let's call this car on take any damage event. Oh god, it's saving again. Let's just put you'll notice that sometimes you have to kind of look for those particular nodes. I was trying to find a way of binding this event, and I couldn't for the life of me figure out like, you know, there's no create event or anything here, but out of interest I kind of thought, okay, let's see if there's any take any damage. It creates an event with the right signature. So basically these delegates expect a certain type of event with a certain number of parameters as input before they'll bind to it, and you'll get an error if you don't bind to the correct type of event. So that's something you should look out for. If you've got a binding here for any kind of binding, have a look in your palette. If you go to window palette, it'll bring up this view here. You can just type in the name of the node, so take aiming damage as the event. What that means is that we can get this guy, and we can say the thing that was instigated by, so this is the controller that it passes in, so we can get control pawn again. So this is the guy that did the damage to us, and we can say add actor, oops, well, we can add actor to threats, and this is the input that we're going to do. We can, oop, why did I not connect that guy. We probably want to print out just to make sure that we've got some like notional awareness of who's going in. So let's just do that now. Let's just do a print string. And all we're going to do is we're just going to pass this guy into here. Oops. Yeah. That's kind of weird. It doesn't like that. Let's just do it to string. That's weird that it didn't do that, isn't it? Compared to the one it did before, but whatever. So we're adding the actor to the threats array, and then we want to handle the actual damage itself. So let's just save and compile. So one thing we need to do is we need to add a new function, and what it's going to do is it's going to take the damage from that actor and just make sure that the damage is correctly handled. So let's add a function here. Apply damage, what do we call it, from actor. Sounds alright. And what it's going to take as input is well, what do we need? We need an actor, which is the guy who's going to do damage to us. So let's just so we can sort these out a little bit. An actor as input. Actor. And how much damage they did. So let's do a float for that. Damage. And the reason why we're doing this here is that we want to be able to apply damage from any incoming actor and set it into so imagine that we've done damage and we've received that event. Well, the event can be received any time, so we need to find the threat that's that actor represents and make sure that we update its damage value. So basically we're going to do a for loop again. So one thing we first off is valid. Make sure we do that check first. So if this guy is valid, then we're going to do let's just do a threat struct, a for loop. We're going to do a for loop with break this time because obviously we only want to really do it on that one guy. So that guy's valid. We're going to break that threat struct. Let's just drag that up there, and whenever we do a break, we probably don't want to do it make because we're going to set it. Oops, let's just pull that up there a bit. So really all we're really concerned with is this damage received thing, right? So we're going to pass everything else straight through. We're not changing last scene. So this one we're going to add the received damage from over here. We're going to pass that in. So basically just adding to that variable essentially, and then the distance and the rank and stay the same. We probably don't really need these two. We probably should delete it from our threat struct at some point, but I'm sure you can handle that. Okay, so in our loop body, what are we actually going to do? Well, we're going to say if the actor that we've just seen equals the guy we're looking for, the damaging actor. Let's do an if. So if this guy is true, then what we want to do is we want to get threat struct again. Want to set array element from the loop. So we just drag that index. Let's just drag that down a bit. And then after we've finished, we want to break out of that loop because we've found the guy we were looking for and updated his values. And then the final bit is we just want to take our new values and shove them in that array index. So let's save and compile that. So basically, whenever we get whenever we see a damage event happening, we're going to get the guy who's caused the damage. We're going to get the amount of damage. We're going to loop through the array of threats looking for the guy who damaged us. So if this is equal, then this is the guy who's damaged us, and we're going to update his threat struct with the amount of damage received. So we're going to add to the damage received value here and save it into this threat struct and update that index. And then once we've done that, because we know we've got a unique character in the array, we can just exit out of it by breaking that loop. So there's a couple of things we still need to do. We need to pass that. Let's go back to our event graph. So we've added actor to threats. What we want to do is then apply damage. So we're going to take this guy and we're going to call our apply damage from actor. And the damaging actor is whoever instigated it. Well, actually, no, it's the pawn of whoever instigated it. And the damage is how much damage it's done. So let's just take this and give it a comment. Bind event handler in case we take damage, so we can remember it for threat selection. So essentially this part this set of nodes handles the damage event, for us. Handles the damage event for us by binding to ourself an event, or rather binding to our control pawn. So the character that we're controlling, we're going to bind to one of his events, his or her events, I suppose. We're going to bind to one of their events to say, right, okay, so we want to know when you take damage, and we're going to handle it by getting the person who did damage, getting their control pawn. So this is the controller that did the damage. We're getting the pawn that controlled it. We're going to add actor to the threats if it's not already in there, but if it is in there, it'll just ignore it in this. And then we're going to apply damage from that actor. So we're going to handle what that actor did to us, essentially adding to its amount of damage it's done. so that when we calculate the utility score for the damage, this value will go up based on how much damage it's done to us. So if it does 100 damage to us, then the utility score of this will effectively be 1. If it's done no damage to us, the utility score for it would be 0. So we're just adding these two. And you could do a whole bunch of different like utility functions here. Like this one's a distance, this one's the damage it's done to us. There might be others, like, you know, whether it's in cover or whatever. Oh, which brings me to another point, and that is that I had a word with Mishka about this whole idea of like utility scoring stuff, and it struck me that the EQS system, although it isn't quite ready yet to work, is actually a much better way of doing that, because it's easier to set up and it's actually more performance friendly as well. And he kind of agreed with me that like EQS would probably be good for utility based decisions. So what we'll probably do is we'll just get this working in this system now, and then we'll get the utility based decision making thing. We'll rewrite this essentially using the EQS system, but that EQS system is still experimental, so we'll probably wait until 4.7 comes out and then do this system again in a much more efficient way. So this is kind of quite, if you look at the nodes, it's quite heavy blueprint work really for what is essentially just scoring some values. And I'm kind of cognizant of the fact that this is getting quite complicated in terms of a tutorial. It's a little bit, it's not exactly what I would prefer to do for tutorial stuff. I'd rather we get a decent amount of functionality in a few nodes rather than quite a lot of nodes like this. But it's useful to know how to do this kind of thing in your blueprints, so it's not wasted effort so much, but we definitely can do it more performance friendly with the new EQS system in 4.7. So we're going to have a quick break here and slurp a cup of tea, and then we'll get on to the next video. Okay, so the last part of what we need to do here is we're evaluating the threats, but we need to kind of forget some of them, right? We don't want the threats to always be constant. So one thing we want to do, or one thing we can do I suppose, is that we can let's just do it over here. I suppose we can create a custom event. Let's call that expire threats. So let's just, oh, it's saving again, lovely. So before we bind our event handler, what we can do is we can update this a little bit and set timer. Let's just start a timer with expire threats. And let's do that sort of once every second or so. We do want it to loop because it's going to be calling that a few times. So what we want is a function that let's do a function and call it remove expired threats. Now our remove expired threats function doesn't need any input parameters because it's literally going to just remove anything from this threats array that has gotten over a certain age. So we'll probably want to say, okay, so how old can this thing be before it's expired? So let's do threat expiry delay, make sure it's public. So we're going to do a for each loop again. Now one thing we can't do is we can't modify this threat struct. We can't delete anything from it while we're looping over it. So that's something to bear in mind. When you're playing with arrays, you can't, if you're doing a for loop, you can't delete anything during the for loop or things will get bad pretty quickly. So let's do a for each loop. And one thing we're going to need is a an integer array. No, we can't use integers, can we? We've got to use the threat struct. Threats to remove. And the reason we need this struct is because so we're going to loop through this body, we're going to see if the thing's expired, and we're going to save any that have expired into a new local array. And then when we've done that, we're then going to when that's completed, we're going to do another loop that takes all of the things we've added to this array and deletes them from the threats array. It should become clear. Well, let's do that part first. So what we're saying is we're going to loop over our threats. Let's just drag that over there. Loop. So it's a for each loop because we want all of them to be deleted, and we're in the loop body. We're going to call the threats, and we're going to remove an item, and the item is this guy. And then we're going to in this guy here, when we're completed, we're going to clear the array, just so we know. So essentially this should, in our loop body, remove anything in the threats array that's been stored into our threats to remove array. Hopefully that makes sense to you. So let's have a look at how we're going to do that. So we're going to do a break again. This time we're only testing these values, so we don't need to do anything particularly for it. One thing we want to do is we want to say if this is greater than or equal to our threat expiry delay. So let's just do an if branch there. So what we're saying is we're going to add this array element to our threats to remove. So let's get that and do an add. So if it's true, we're going to add this array element here. And let's just make sure we've got something. So print string, and let's just say something useful here. So removing, let's just zoom in on that so I can actually see what I'm typing. So what this is doing is basically saying actually we kind of want this to be a sequence, don't we? So let's do sequence. So we're going to expire if our actor is valid. So we want to do that bit first, so it adds it to our threat structure. If it's actually, no. We only really want to do one of these things, don't we? Well, so this, let's just comment this, expire threat if time since we last saw them is greater than threat expiry delay. What we want to do is we want to test to see if the thing's still valid. And if it's not valid, then we want to do the same thing. We want to add to this. So rather, if it's not valid, then we're going to add it to the threats array. So let's just, copy these guys. Help if it actually highlight it. So I'm going to say if it's not valid, then we're also going to add it to removing invalid. So we've got two ways of removing threats. One is that if the threat's expired, i.e. we haven't seen them for a while, and we'll just get rid of that as a threat. And the other one is if the threat is now no longer valid, as in, i.e. the actor that it was a threat, the actor that was a threat is now not an actor anymore, it's been destroyed or whatever. We can get rid of that in the same way. So let's just comment that one up. Remove any threats that are now invalid. Yeah, so basically adding it to this threats to remove array, and let's just add this guy. Yeah, so basically we're saying the element is added to the threats to remove array if it's not valid, or rather if the actor in it isn't valid. And then finally this bit is the bit that actually does the removal. Remove actors from the threats array. Remove these from the threats array. Okay, so this part expires the threat, this part removes it if it's invalid, or rather tags it for removal if it's invalid, this one tags it for removal if it's expired, and then this part actually does the removal. So then we just need to call that and save and compile. Let's just save everything. File save all. Considering how many times it's saved automatically, you'd think it would have saved all anyway. Okay, so going back to our event graph, all we need to do now is call that function, right? In fact, let's just call it from here. Remove expired threats. So that's all our code. I think we've got everything. So we run our behavior tree, we set a timer which then calls the expired threats and removes any expired threats. We bind an event handler in case something causes damage to us, so we can add it to the threat structure and update its damage value. This is as it was before. If it sees an enemy, it adds it to the threats. It also binds an event if this if the thing that's being added to the threats is destroyed, then we call a garbage collector to make sure that that reference goes invalid quickly. Basically, if you don't call this, the garbage collection could take up to about a minute, so 60 seconds apparently is the normal, before an actor's actor reference goes from whatever the actor was to invalid. So you could just disable this pin and watch what happens, and what you'll find is that, like, your AI guy will go and beat up on somebody, that guy will die, and the actor will the AI guy will still be beating on him because he's not aware that he's aware that something's died, but isn't aware that that particular guy's died, and actually nothing's aware that that guy's died until 60 seconds after he's done it, which is kind of weird. And I think it seems like a bit of a bug, but hey, what am I? Just a nobody. So in our tick, we're essentially saying evaluate enemies. Yeah. So this is a way of just gating the time to say we're not going to run this every single update. So evaluate enemies at the evaluation frequency, which calls this event here, which then goes for calculates the utility score, finds the highest, sets the highest into our current target as the blackboard, on the blackboard for this actor. So that's it, really. That should be our code done now. Shall we comment this one up? Let's just add a quick comment. So there are a few things we probably want to do. So max health should have a value of, let's say, 100. Threat expiry delay, let's say 10. You can tweak all of these values. Threat evaluation frequencies 5. What else is there? Yep, so I think it's about time to go and try the code. Just compile it and save it. So let's have another quick break and then we'll go and play it. Okay, so final bit just before we actually run it is we want to make sure that this threat distance curve is set to our curve that we did before. So make sure you got that selected. So that threat distance curve, if we just open it up, is essentially this. So it's the relationship between distance and utility score. So what we're saying is we've got kind of maximum utility value the closer it is to us. Now this curve is probably a little bit wrong actually. We probably want more of either a sort of scooped out curve or a sort of linear thing, because what we'll actually get is a lot of like 0.999 kind of values up here, and then essentially 0 as we're getting past sort of 40 meters. Is it 40 meters? Yeah, 40 meters in the world. But you can see that like you could edit this curve to give you different like utility profiles. So this one's for the distance value, but you could, you know, do curves for all sorts of different things and just add them all together or multiply them together. Yeah, so let's just save that. So let's run this bad boy. Let's just save, make sure we've got everything saved. And what we should get when we run it is, as you saw before, this guy's got 3 threats and he's evaluated them all as like 0.9. If I throw my projectile at him, he sees me as a threat and starts aggroing on me, which is what we want. And you can imagine that those AI guys would normally be like actually doing something. Now watch as the weight score for me goes down, right? It basically, as I'm running around, he reevaluates that score, and at some point the damage that I've done to him is kind of scored out. Trouble is he's the same speed as me, so I can never get away from him. The damage I've done to him gets scored out and he'll go back and attack those guys. So if I just manage to lose him, he then goes and nope, he's still enraged on me. At some point there he goes. Right, so he's basically aggroed on them, and that's essentially how you do you know, the whole mob chain thing in MMOs. That's how those work. It's essentially they kind of have some utility value for each guy and have a thing that diminishes that utility over time, and then, you know, so you can aggro on them. Yeah, I'm aggroing him again. Oh, he's after me. He's definitely going to kill me this time. But I've got the leap. Woohoo! Oh, don't take him through the waypoints or he'll start following the path. Ooh. Yep, he's got bored of me now. Oh no. See, when he can't get a path to me, he'll go and attack one of those guys, which is kind of useful. So if I'm in the air while he's calculating his path, he will literally go back and attack them. And then he attacks me, because I'm the biggest threat to him. And that's true, I am. So there you go. I think we'll call it quits for this version of the Mob AI and come and redo it again once the EQS system goes live. We'll just watch him kill a couple of guys, because, you know, that's the way he rolls. So get in touch if you've got any problems. I know it's quite a complicated one this time around, and I'm kind of cognizant of the fact that it's a little bit it's not the cleanest interface in the world, is it really? Frankly, it's not the nicest to have like a really complex blueprint for what is essentially just scoring some behaviors. So we will do this in the EQS system, or something like it in the EQS system, because ultimately EQS is kind of the right type of system to use for this. So this guy will kill all 3 of them and then come after me. Yeah, I mean, it works, but honestly it's actually kind of a bit slow in blueprints. I've noticed that blueprints are a bit too slow to do some of these things. You really want to do only event-driven behavior in blueprints. So doing this kind of per tick evaluation update thing is kind of not good. So there we go, he's figured out that he's now hates me more than everybody else because there's nobody else left. And then he'll hunt me down and kill me. Well, he'll try to. But I'm invulnerable, even though my health goes down to 0. So there you have it. That's the end of that particular series. Thanks for watching. Leave any comments on the video. I will try and help you through it because I know it's kind of hairy. I'll actually put the files up, I think, for this one. But of course they are 4.4.3, so they might not be that useful. We'll see. I'll see if I can clean up the code base and post it somewhere, because I've got a lot of stuff from a few other projects, sort of Mixamo and all that kind of thing, so I can't really give you those. But there you go. Hopefully you'll have had a little bit of fun playing around with utility values and maybe making your own. Obviously the utility functions themselves can be all sorts of different things. I like using the float curve way of doing things. I think that's kind of useful. Thanks for watching, and I'll see you in the next one.